In this video, we are going to continue with some more questions based on matrix multiplication. So here is one question. It says, find a matrix A such that this matrix equation exists. So I have a matrix equation here where you have an unknown matrix A which is to be found. So our aim is to find this unknown matrix. But to be able to figure out what matrix A is, the first thing is I should decide upon the order of this matrix A. So I'm going to write the order of the matrix here. So when I look at the first matrix, it is a 3 by 2 matrix. You can see that that's the first row. Horizontally I should count 1, and then I count the second row, and then I look at the third row. So there are 3 rows horizontally, 1, 2 and 3. And then there are 2 columns. That's the first column, and then that's the second column. So it's a 3 by 2 matrix here, multiplied by an A matrix for which I don't know the order, so I assume it as m by n. But I know the answer matrix. The answer is going to be a 3 by 3 matrix. We know it. So that's the answer matrix. It's a 3 by 3 matrix there. But we know that for matrix multiplication to be possible, these two middle numbers are supposed to be the same. So 2 and m are supposed to be equal, which means m is equal to 2. I already know. So I know that m is 2. And then the remaining numbers will give you the order of your answer matrix, which is 3 by n. So I cancel the middle numbers because they are supposed to be the same, and then the answer matrix will be a 3 by n matrix. So 3 by n matrix is equal to a 3 by 3 matrix, which means n has to be equal to 3. The second numbers, you see, n is equal to 3. So I figured out that m has to be 2 and n has to be 3. So the m is 2, n is 3. So the order of the matrix A is 2 by 3. So what you are looking for is a 2 by 3 matrix there. So this is what I am looking for, a 2 by 3 matrix. So since I know the order of matrix A, I am going to make an assumption. I'll say let A matrix, A is of order 2 by 3. Therefore, let A be assumed as matrix ABC, DEF, which has got 2 rows horizontally, 2 rows, and then vertically you have 3 of them. There are 3 columns. So it's a 2 by 3 matrix. We assumed it as A, B, C, D, E, F. So we found the matrix A. So what I'll do is I'll go back to equation number 1. I'll copy this first matrix as it is. In place of A, I will write this assumed matrix, and then I'll copy the right hand side. So let's see this. This is equation number 1 becomes I copied the first matrix as it is, and in place of A matrix, I'm going to write A, B, C, D, E, F. Is equal to the right hand side matrix I copy as well. And then on the left hand side we are going to do matrix multiplication. And how do we multiply matrices? The row goes with the column. So I take the first row and multiply with the first column, then the first row with the second column, then the first row with the third column. So with the first row you will multiply the first column, then the second column, then the third column. And then you will repeat with the second row and then with the third row. So let's do that multiplication. So 2 minus 1 will go along the first column. So 2 minus 1, the first row goes along the first column. So 2 into A is 2A plus 1 minus 1 into D is minus D. So that means you get 2A minus D. Then the first row goes with the second column. So I'll get 2B minus 1E, 2B minus 1E. And then the first row goes with the third column, which will give me 2C minus F. So with the first row, I multiplied all the 3 columns. Then I take the second row 1 0 and multiply all the 3 columns as well, which will give me 1 0 going along the first column, 1 0 the second row with the first column. 1 into A is A plus 0 into D is 0. So I write only A plus 0, which is A. Then the second row goes with the second column. 1 into B is B plus 0 into E is 0. So I get B, 1B plus 0, which is B. Then 1 0 goes along the third column. 1 into C is 1C plus 0 into F is 0. So 1C plus 0 is C. So I did the second row into the third column as well. Now the third row, minus 3, 4, goes along the first column, goes along the second column, and then goes along the third column. Minus 3, 4 with the first column, minus 3a plus 4d. So I'm going to get minus 3a plus 4d here. Now minus 3, 4 goes along the second column, minus 3b plus 4e, and then minus 3, 4 goes along the third column, which is minus 3c plus 4f, which is equal to the right hand side matrix, which we already know. Yeah, that's now once we have done this matrix multiplication, it's going to be pretty easy. If two matrices are equal, all their corresponding elements must be equal, which means from the left side, if I pick up an element, that must be equal to the corresponding element on the right side. And I notice that the second row directly gives me the values of a, b and c. A is equal to 1, b is equal to minus 2 there, and c is equal to negative 5 from the right side. So I have the values of a, b and c. I list them out, and then once you have the values of a, b and c, you can go to the first row and calculate the other three variables as well. So I'm just copying this step which we already did there, copied it, and I'm also copying the values of a, b and c which I found. A is equal to 1, b is equal to minus 2, and c is equal to minus 5. I'm going to equate a11 from the left side with a11 from the right side, which means I'll have 2a minus d is equal to minus 1. a11 from the left side is equal to a11 from the right side. But I already know the value of a, so let me plug it in. And once I put the value of a in, it is 2 minus d, 2 into 1. 2 minus d is equal to minus 1. Then I rearrange for d. Therefore, when I rearrange, I'll get d, minus d goes to the right side and minus 1 comes to the left side. So d is equal to 2 plus 1, which is 3. The second element, 2b minus e, we'll say 2b minus e is equal to minus 8. And I know the value of b as minus 2, put it in here. So you'll get negative 4 minus e is equal to minus 8. Rearranging, I'll get e is equal to 4. And then the third element, 2c minus f is equal to minus 10. And I know what c is minus 5. So minus 10 minus f is equal to minus 10. Rearrange it, you will get f is equal to 0. So now that we know the values of all the unknowns, your matrix A is A, B, C, D, E, and F. A, B, C, I put the values in, then D, E, and F, 3, 4, and 0. So that's the unknown matrix. So we solve for A. Look at this question. Find the matrix X such that X, a matrix, into a 2 by 3 matrix is equal to another 2 by 3 matrix. And I am supposed to find this unknown matrix. And if I want to figure out what this matrix X is, the first thing is I should decide upon its order. I need to find the order of this matrix X. Now, how would I find out the order of this matrix? I don't know what the order of X is, so I'm going to call it as m by n. So this is an m by n matrix multiplied by 2 rows and 2 rows, horizontally 2, vertically 3, 2 by 3 matrix. So let me write that. An m by n matrix, unknown matrix, multiplied by a 2 by 3 matrix should give me a 2 by 3 matrix. If you look at the right hand side, the answer is 2 by 3. So an unknown matrix X, so I said the order is m by n, multiplied by a 2 by 3 matrix gives me the answer as a 2 by 3 matrix. And now for multiplication to be possible, the middle numbers must be the same. So I know that n has to be 2 here. And since the answer has to be 2 by 3, m also has to be 2. So that's basically m by n is a 2 by 2 matrix multiplied by a 2 by 3 matrix. The middle numbers will cancel and I'll get a 2 by 3 matrix. So the order of m by n, pretty easy to figure out it as 2 by 2. Now you must definitely think in your own way and figure out what could be the order of this matrix XB. So X is a 2 by 2 matrix multiplied by a 2 by 3 matrix. The 2 by 2 matrix multiplied by a 2 by 3 matrix. The middle numbers are same, so the answer will be a 2 by 3 matrix. 2 by 3 matrix, perfect, you see. So what you are looking for is a matrix X which is of order 2 by 2. So I will talk about the order first. X is a 2 by 2 matrix. And if X is a 2 by 2 matrix, I'll say let X be A, B, C and D. So I have assumed the matrix X as A, B, C, D. So I'm going to go back to this equation and I'll replace the unknown matrix X by the assumed matrix, which is A, B, C, D. So I'll write X matrix as A, B, C, D into the next matrix is 1, 2, 3, 4, 5, 6 is equal to the right hand side matrix -7, -8, -9, 2, 3, 6, which I copied here. Now this is a 2 by 2 matrix multiplied by a 2 by 3 matrix should give me a 2 by 3 matrix as the answer. We already checked it. So I'm going to do that matrix multiplication. We know that the first row goes along the first column. How do you multiply? First row goes with the first column. A, B will go along 1, 4. So 1 into A plus 4 into B, which means 1A plus 4B is what I have to get there. So first row into the first column gives me 1A plus 4B. And the first row then goes along the second column. That will give me 2A plus 5B. Then the first row will go along the third column, which is 3A plus 6B. So let me complete that row now. So that is B going along the second row is 2A plus 5B. And with the third column, it is AB going along the third column is 3A plus 6B. So first row into the first column, 1A plus 4B. First row into the second column, 2A plus 5B. First row into the third column, 3A plus 6B. Now I have the second row, CD going along the first column. What is that going to be? CD going along 1, 4. 1C plus 4D. So that is 1C plus 4D. Then CD going along the second column, which will be 2C plus 5D. And CD going along the third column, which will be 3C plus 6D is equal to right hand side. I just copy as it is. What do we do this time? This time I don't get a set of values like how I got in the previous question. I need to make simultaneous equations. I have A11, which is A plus 4B is equal to 7, which has got two unknowns in it. And so that means I need to pick up one more equation in A and B. So I'll take 2A plus 5B, A12 is equal to -8. So I'm going to say A plus 4B is equal to -7, one equation. Then 2A plus 5B is equal to -8, second equation. So we're going to make two equations like that, and then we will solve them. That's my first equation, equating A11 from the left side with A11 from the right side. And then A12 from the left side is equal to A12 from the right side. So I have got two equations, and if I want to solve them, I should make either the A coefficients the same or the B coefficients the same. It looks like making A coefficients the same easier because this is 2A here. So what I have to say is equation number 1 should be multiplied by 2. And second equation, keep the same. So first equation multiplied by 2. So what do I get? 2A plus 8B is equal to -14. Second equation, copy as it is into 1. And now if I want to get this 2A cancelled, I need to subtract them. Change the sign and add or subtract it. So by subtracting, 2A minus 2A will go away. 8B minus 5B is 3B is equal to -14 minus -8. -14 plus 8, which is -6. 3B is equal to -6. So B is equal to -2. So I found the value of B, which I'm going to put back into one of the equations. So if I put it back into the first equation, it will be A plus 4 into -2. So that's going to give me A minus 8 is equal to -7 from the first equation. So to find A, I move this -8 to the other side. So A will be equal to -7 plus 8. -7 plus 8 is 1. So I got the value of A and I got the value of B. What I'm going to do is I'm going to copy this equation onto the other side one more time, and then I'll make another pair of simultaneous equations in terms of C and D. So this is my original equation after multiplication what I had. I'm going to make a pair of simultaneous equations which are in terms of C and D. So C plus 4D, that's the second row first column element from left side is equal to second row first column element from the right side. Corresponding elements, C plus 4D is equal to 2 and 2C plus 5D is equal to 4. And I need to eliminate one of the variables, and here again eliminating C looks easier. So this is 1C, this is 2C. So multiply equation number 1 by 2. Equation number 1 into 2 will make it 2C plus 8D is equal to 4. And equation number 2, you keep it as it is because it's already 2C. And then you subtract them. When you subtract it, you get 8D minus 5D as 3D is equal to 0, which means D is equal to 0. 0 by 3 is 0. Once I get the value of D, I'll substitute this back into one of the equations. Into the first equation, if I put C plus 4D is 2, but D is 0, I know. So C plus 0 is equal to 2. Therefore, C is 2. So we found the values of A and B earlier, and now we found the values of C and D as well. And therefore, your matrix will be A, B, C, and D. A was found to be 1 earlier. B was minus 2. C, we just found it here. C is 2, and D also we found here 0. So A, B, C, D. So that's the required matrix. I'm going to keep 2 questions for you to try on your own. You should pause the video, write it down, and make an attempt to do this. If you look at the first question here, find B if this matrix equation is given to me. It's a 2 by 2 matrix here, and the answer is also a 2 by 2 matrix. So what should be the order of B? That's the first thing you need to figure out. 2 by 2 into something should give me a 2 by 2. Oh yeah, that's going to be 2 by 2 again. So I know the order of B is 2 by 2. So I will assume B matrix as A, B, C, D. It's a 2 by 2 matrix. And then you multiply them, equate it, find it. There's a shortcut on this which I will discuss with you a little later using the concept of inverse. You can pre-multiply both sides by the inverse of this matrix and directly I can get B. That's an alternate method. I wouldn't say that it's so much easier than this or something, but it's an alternate method. But that works only when the matrix which is to be shifted to the other side is a square matrix. Otherwise, you can't take inverse. It's an alternate method. Don't worry about it. You will say B is of order 2 by 2. Therefore, B can be assumed as A, B, C, D. And then you do the matrix multiplication, make simultaneous equations and solve. It's pretty much the same way, but the order of A you need to figure out. It's not 2 by 2 because 2 by 2 into another 2 by 2 will only give me a 2 by 2 matrix, but I have to get a 2 by 3 matrix. So what should be the order of A? Figure it out, then try to multiply them, make equations and solve them. We're going to look at another question here. It says, if A is not equal to 0, use the principle of mathematical induction to prove that A raised to n is equal to A raised to n, n A raised to n minus 1, 0, and A raised to n, where A matrix, the original A matrix, is A1, 0, A for every n belongs to the set of positive integers. So that's our question here. We need to prove this identity, A raised to n is equal to whatever is given to me. That's what I need to prove when it is given to you that your basic A is A1, 0, A. Now this has to be proved by mathematical induction. Even otherwise we know any result which is true for all positive integers can be proved by principle of mathematical induction. This is from class 11 what you have learned. So there are 3 different stages where we prove this. First, we will call the result to be proved as P of n, if you remember, or some people just write Pn, or I write P of n. So that's P of n, and then I'll say prove that this result is true for n is equal to 1. That's stage 1. I'm quickly reminding you what the usual method is. Then you will find out, you will assume that the result is true for n is equal to k, and then using that assumption you will prove that this result is true for n is equal to k plus 1. And then you will write by principle of mathematical induction all that usual conclusion. So I'm not going back to the theory of induction method. I'm just going to follow the method of principle of mathematical induction to prove this result. This is the result I have to prove. So you had one whole chapter on mathematical induction last year. As I do this, you will remember. So I'm going to call the result to be proved as P of n. So I said let P of n be the result which is to be proved. There are 3 stages, and the first stage is assuming n is equal to 1. And I need to prove that this result Pn is true for n is equal to 1. And if I want to prove that this result is true for n is equal to 1, I should do the left hand side of it first, get some answer. Then I should do the right hand side of it, get an answer, and show that both are equal. So I'm going to do the left hand side. What's the left hand side? A raised to n, but n is chosen as 1. So a raised to 1, a raised to n became a raised to 1. A raised to 1 is a. So I leave it there. So that's my LHS. Now what is the right hand side? Right hand side is a raised to n. So I make n as 1. So a raised to n on the right side becomes a raised to 1. I wrote it as a. Then 1 into a raised to 1 minus 1. 1 minus 1 is 0. A raised to 0 is 1. So 1 into 1, that's 1 there. Then I have 0, and then a raised to 1. A raised to 1 is a. So look at that. Look at what we have got there. So that's going to be, I just replaced n everywhere by 1, and this is what I have. Now a raised to 0 will be 1. So 1 into 1 is 1. So what do I have there? I get a, 1, 0 and a. And that's nothing but, if you go back and read the question, a, 1, 0, a is your a. So I'll say that's equal to a. So my left hand side got simplified to a. The right hand side also got simplified to a. So LHS equal to RHS. And if LHS equal to RHS, that means I proved that this result is true. The LHS and RHS came equal, but when n is equal to 1. So I'll say LHS equal to RHS means the result is true for n is equal to 1, or rather I say P of 1 is true. So that's your first stage in induction questions. Prove that the result to be proved is true for n is equal to 1, or rather P of 1 is true. There are 2 more stages, and in the second stage, what do we say? In the second stage, we make an assumption. We say assume that P of k is true. What's the meaning of it? Assume that the result, or the result to be proved, is true when n is equal to k. Assume that this result is true for any natural number n, any positive integer n, any random positive integer k. So I'm going to prove that the result which is to be proved here is true for any positive integer k. So k stands for any positive integer. So I didn't actually write it there, but then that's the meaning of it. So I'm going to add it there. So now, where k actually belongs to z plus. So that's the assumption I am making. I'm just saying that I'm assuming that the result to be proved is true for n is equal to k, which means it's only an assumption. Don't forget that it is only an assumption. So that means under my assumption, a raised to k will be equal to a raised to k, k times a raised to k minus 1, 0 and a raised to k. I simply replace n everywhere by k. So that's an assumption, or we assume that this is true. So we assumed that the result is true for n is equal to k, where k is any positive integer. So like I am saying, let it be true for 100, or I am saying let it be true for 500, but not for a fixed number. I am saying let it be true for any random positive integer k. But remember, this is only an assumption. So that's where we have a third stage. Okay, before I go to the third stage, I'm just copying the equation which I had under assumption earlier, which I just copied here. This is my P of k. Now, third stage is I'm making a statement here. Now, I need to prove that P of k plus 1 is going to be true. I assumed that the result is true for n is equal to k. Now, I'm saying under that assumption, assuming that it is true for n is equal to k, I want to prove that it is going to be true for the very next number, which is k plus 1. If it is true for n is equal to k, I want to prove that it is going to be true for its very next number, k plus 1, which means I need to prove that a raised to k plus 1, because for the very next number, so wherever k comes, it should be k plus 1. So a raised to k plus 1 is equal to right hand side, a raised to k plus 1, the next element, k becomes k plus 1, a raised to k plus 1 minus 1 is k, second row, 0 is 0 itself, a raised to k becomes a raised to k plus 1. So this is something which we have to now prove. We are trying to prove that this is true. We are trying to prove that P of k plus 1 is true under this assumption. If it is true for k, we are trying to prove that it is going to be true for k plus 1. And to prove anything, I need to start with the LHS. So I'm going to start with the LHS. I'll say LHS is a raised to k plus 1. And a raised to k plus 1 I can always split as a raised to k into a raised to 1. Of which a raised to k, I have an equivalent expression here. What is a raised to k? I know from my equation number 1. But remember, it's only an assumption. So by my assumption, I know what a raised to k is. So I am going to replace it. And a raised to 1 is a, which is given to me in the question. I can copy from my question. So I'll copy a raised to k's value from equation number 1, which is an assumption. And what is a? It was given to me in the question, A10A. And that's usual matrix multiplication. So how do I do my matrix multiplication? The row goes along the column, and you got to do that carefully. Row goes with the column. First row with the first column. A raised to k into a is going to be a raised to k plus 1 plus k times a raised to k minus 1 into 0 is 0. Look at that again. The first row with the first column. A raised to k into a is a raised to k plus 1 plus this element, the second element into 0 is 0. Now the first row goes along the second column. A raised to k, first row with the second column. A raised to k into 1 is a raised to k plus k times a raised to k minus 1 into a raised to 1. K would stay. A raised to k minus 1 into a raised to 1. A raised to, add the powers, k minus 1 plus 1 from here, which is k. So k times a raised to k. So the first row with the first column, I wrote it. First row with the second column also I wrote. Now comes the second row. Second row into the first column. 0 a raised to k goes along the first column. 0 into a is 0 plus a raised to k into 0 is 0. Now second row goes with the second column. 0 into 1 will be 0 plus a raised to k into a is a raised to k plus 1. Let's just rewrite that one more time. A raised to k plus 1 plus 0, which is a raised to k plus 1. Here a raised to k is common factor. I take a raised to k common factor. So what do I have here? K plus 1 balance. A raised to k common factor into k here and plus 1 here. So k plus 1 into a raised to k. This is 0 and that's a raised to k plus 1. But if you go back and see, we were trying to prove a raised to k plus 1 is equal to this. I started with it at its left hand side and I ended up getting the right hand side. So this is exactly same as my right hand side. So I'm going to say this is equal to my RHS. So what did I actually prove? I proved that my P of k plus 1 result is true, or the result is true for k plus 1. I proved P of k plus 1 is true, not always, only if P of k is true, because we made P of k only as an assumption. We just assumed that P of k is true. So now what we did is we proved that P of k plus 1 is true whenever P of k is true. So P of k plus 1 will be true if P of k is true, which means we are saying that for any random positive integer, if the result is true, it will also be true for its very next number. Think about it. Assume that it is true for 50. Then we proved that it is true for 51. We actually proved it, but we have to assume that it is true for 50. So if it is true for 50, it will be true for 51. If it is true for 100, it will be true for 101. But what is interesting is that we already proved that P of 1 is true. We actually proved, not an assumption. We actually proved that P of 1 is true. Think about it. P of 1 is true. So it has to be true for P of 1 plus 1, which is P of 2. So we proved that it is true for P of 2. Now P of 2 is true. Therefore it has to be true for P of 2 plus 1, which is 3. So P of 3 is true. Now P of 3 is true. Therefore P of 3 plus 1, 4 is true. So P of 4 is true. So it has to be true for P5. P of 5 is true. So it has to be true for P6. So it never ends, and that is called the principle of mathematical induction. So we just say, therefore, by principle of mathematical induction, the result Pn is true for all positive integers. I'm not keeping a homework on it because I did only one question on it. So what I'm going to do is I'll make another video, and in the next video we'll do some more questions on mathematical induction. What you need to do is you should write it down and then make an attempt to do this question all by yourself without looking at any of the steps, and that's how you learn it.